In this video, I'll show you how to make 3D characters move smoothly relative to the camera in Godot 4. Watch as I press A. So you can see my character moves left, just as you'd expect, even while I rotate the camera. So there's no more confusing controls or drifting off into the water or off the road, right? So yeah, let's get right into it. Right off the bat, we're going to create a 3D scene. Then let's create our character body 3D and save the branch as a scene. Then we can enter that scene and get to work. Now within the scene we need our camera to see what's going on, and that is why we're going to create one right over here, and we're gonna position it slightly above. By the way, I'm holding shift to drag the camera position along one axis so that it doesn't move across multiple axes. We're going to rotate it slightly down. And then for our character, we are going to create a collision shape and a mesh instance. Mesh instance is for the visible portion, aka what will be displayed, and collision shape is a shape that can collide with other objects. So I'm going to quickly create the character, and we're going to attach a script to it now that we've got a camera and the character. So the script will be attached to character body 3D. Right click it and go to attach script, then create, and let's start. First, we need to create a reference to our camera. I'm using an onReady variable to grab the camera 3D node. This lets us access the camera's orientation every frame. Since the script is attached to the character body 3D node, this reference points to the camera inside our character. Next, I define a constant for the movement speed at the top of the script. This makes it easy to tweak how fast the character moves later on. Now everything happens inside the physics process function, which runs every physics frame, which is about 60 times per second, and this is where we'll handle all our movement logic. We create an input vector using Godot's input.getActionStrength for moving right, left, forward and back. The x value is right minus left and the y value is forward minus back. This vector tells us which direction the player wants to move. For example, if the player is moving right, the first value will be 1. If they're moving forwards, the second value will be 1. If they're moving left or back, those values will be -1. If the input vector isn't 0, we have to normalize it. This step is important because it keeps the movement speed consistent, even when moving diagonally. Without normalization, moving diagonally would make your character go faster than moving straight, which we don't want. So normalizing the vector sets its length to 1, so speed stays the same in all directions. Now we get the camera's orientation using its global transform basis. This gives us the camera's forward and right directions in 3D space. The basis contains the scale and rotation of the camera, and we use the rotation to see which way the camera is facing so we can walk in that direction. We determine the forward direction using the camera's z-axis. We set the y value to 0 and normalize it. We do this because we want the character to move on the ground, not up or down if the camera is tilted. We do the same for the right direction, which is the camera's x-axis, again, setting y to 0 and normalizing it. To calculate the movement direction, we multiply the x part of our input vector by the right direction, and the y part by the forward direction. If we're moving right, the x value is 1, so we move in the right direction. If we're moving left, the x value is -1, so we move in the opposite direction. And the same logic applies for forward and backwards using the y value. Adding these together will give us the direction the character should move in relation to the camera. Finally, we set the character's velocity x and z to the movement direction multiplied by our speed constant. This makes the character move smoothly in the direction we calculated. We also normalize the movement direction so that the speed is always consistent. If there's no input, we set the velocity x and z to 0 so the character stops moving. And finally, we call move and slide to actually move the character in the game world. and the only remaining thing for us to do is to test this out. And when we play the scene, you can see everything is working as expected. However, one flaw you may notice is that when I press to go forward, W, I will actually go backwards instead. And this is not a flaw, it is actually just due to the direction our camera is facing. As you can see, it is facing the cube, however it should be rotated the other way instead, aka it should be on the other side of the cube. We will fix that just by putting a minus in front of the camera bases.z. So yeah, let's try it out again, and everything is working fine now. So I hope you enjoyed, hope you learned something, and yeah, that's it. Bye.